Let's look at stone versus brick. What are the similarities? So both are stacked, both use mortar joints. What are the difference? The shape. Bricks are molded while stones are cut and carved. What are the physical properties? Brick can be controlled. They are made. So they're the mixture of the composition of a brick. Stone is provided by nature. Types of building stone for building construction. So we have granite, limestone, and sandstone, slate, and marble. Granite, it's non-porous, hard, strong, durable, expensive, right? So there's a different color range. Surface texture could also be achieved. There are different sources. Okay, so what are their primary uses? So it could be polished surface or rough and textured. Could be used for interior and for floors and walls in the interior. And it's also used in the exterior. So it could be for covering, veneer, and in some cases, even used for pavements, pavers. Limestone, it's porous, relatively weak. There are different color ranges as well. Surface texture sources, primary uses. So limestone with granite. So limestone there, granite at the bottom. Simulated limestone cladding. Okay, and then we have marble and slate. So marble, slate. Normally slate is used for or as a roofing material. So there are field stone, rubble stone, dimension stone. Okay. So depending on where they're quarried, and we can cut them into blocks, sawn into slabs. These are the different sizes and thicknesses. Slab fabricated to desired size and finish. Because there's the cost that we need to consider, and then the lead time for its shipping, right? Polishing, okay, being customized. It could take months. Okay, this is a rubble. They are on square pieces. Ashlar, square pieces. Coarse or random. And then you can change the orientation. This is a random rubble. Very random, very beautiful, rustic. Okay. Laid in mortar like bricks or mechanically fastened in large sheets to support system. So this is a fastening system. You have your CMU, and then you will have your stone in tile format. Okay, connected through the straps, anchored, and providing weep holes. There's a cavity so that water can drain. Remember, water is the enemy of your materials, so you have to drain it properly. There it is in actual fastener. Okay. Then the stone looks like a granite. Okay. Then the cavity. There are different CMU, concrete masonry unit, sizes and shapes. It's like a jigsaw puzzle, like a Lego. Okay. So you can do different configuration. This is the CMU in picture. Okay, most common CMU sizes, 4, 6, 8, 10, 12. Okay. Nominal will be less 3/8 of an inch to compensate for the mortar. So that will be the mortar thickness. Height, 7 and 5/8. Length, 15 and 5/8. Height is an 8 inch equals 3 courses of bricks. Placement, cause, reinforcing. Okay, so you can see reinforcement, and then its uses and finishes. So it could be used as a steel lintel, blocks lintel with reinforcement, as we've seen earlier, placing the rebar at the bottom for tension. And then it could also be a precast. Okay, so this can be used as a lintel, placing reinforcement bar at the bottom. Joint reinforcing ladder or truss. So you put either a ladder, which is what we see here, or a truss. We'll see a truss later. There you go. Truss. So that is for reinforcement, so it doesn't move. It provides some adhesion from course to course or from block to block. Okay, so here is a picture of a installer doing the, there's a tie or, a thread. So you know how high. This is normally leveled by the water gauge so that you know how high your CMU unit should be for the next course. Okay, so that's a picture of workers, masons doing the layout of a CMU. Then you place mortar. On top of that, you place your CMU. The excess will be placed on top. There will be tool joints. Okay, so there's the ladder reinforcement. And then there are control joints. See, you need to provide for expansion due to weather, freezing, towing, so that your CMU wall doesn't crack. Okay, so that's second part. We'll break for now.